Okay, like we mentioned in the pre-lab, we are using potassium permanganate to oxidize. In the procedure, it tells you benzaldehyde or benzyl alcohol, and that's because potassium permanganate is a strong enough oxidant that it will work. It will take an alcohol or an aldehyde to carboxylic acid. So going by the procedure, we've got a 250 ml round bottom flask, and it tells you to add 8 grams of potassium permanganate, and I will send you the actual amounts I used. So we're starting off adding this to our flask. And whatever you do, make sure you add your water, your 75 mils of water, before adding your alcohol. Adding the alcohol to the permanganate dry can start a fire. Ask me how I know. Someone in our lab did that a couple years ago. And you get a beautiful purple color there. And we're also using 1 gram of sodium carbonate. And now we're setting this up for reflux, which you've done before. The procedure also tells you to add a couple boiling stones, and I've already done that. So now it's just a matter of adding our reflux condenser, and we are letting that run for 45 minutes. And I won't bore you with that whole thing, but I will show you the color change. All right, so we will come back to that. Okay, so after running our oxidation for 45 minutes, we're taking it off for reflux, and you let it cool to room temperature before moving it to an ice bath. And we're just going to let that cool for a bit. Okay, now if all of your potassium permanganate had reacted, you would see just a dark chocolate brown color, but you can see some brown on the sides, but you can see there's still some purple color to it. So to test, what you can do to test to see if you have unreacted permanganate in there, if you just dip a glass stirring rod in the solution, and if you just touch it to a filter paper, you can see the purple ring around it, and in the middle is your manganese dioxide where the permanganate's been consumed. So to consume this unreacted permanganate, we're using sodium bisulfite, and we're just going to add some to the mixture, swirl it around, and we'll test it again. So I tested it a few times, and you'll see I've just got the brown spot, no purple ring, so we're pretty sure we've reacted all of that permanganate. Okay, and after you quenched all of the unreacted permanganate, you just do a suction filtration, which you've done before, so I didn't show that, but you end up with a kind of a clearish liquid there, and this solid mess here, and this is just manganese dioxide waste. So you would set that to the side. You're adding the 10% sulfuric acid because you're wanting to make sure that all of your benzoic acid is protonated. If it's protonated, it'll be poorly soluble in water. If it's deprotonated, you'll never get it out of water. So we're checking for pH here after we add some of our acid, and you want it to be strongly acidic. So we've got a dark red color there, so we know we've added enough, and you can see that our product has really fallen out of solution well. And after this, it would just be, you'll be filtering this out again. So after your second filtration of your benzoic acid crystals, what you obtain, you've got a clean white powder there. What you would do after this second filtration is you would do a recrystallization from smallest amount of water that you can get away with. And then there would be another filtration to get your clean benzoic acid crystals. And the solid recovered there, you would get a mass to do your percent yield calculations and obtain an IR, melting point, etc. Since you've already done recrystallization, I'm not going to go through that. Your IR and NMR data will be on Harvey, and either Dr. Peoples or myself will email you the masses used and the amount recovered and all that for you to do your calculations. With everything we've done, one thing you can be glad you missed out on is the mess. Typically we have this brown and purple stain everywhere that we had to contend with, but now I just have me to clean up after. So thanks for watching, and we'll see you soon.